Chain rule of differentiation. We are going to have 5 examples from easy to insane. Let's recall chain rule of differentiation. Y is a function of u, you can see on the screen, and u is a function of x. So what we do, on the left side, first function and last function dy by dx, and on the right side dy by du into du by dx. So we'll do in the examples. Alright, let's start, and here we are going to use some basic formulae of derivatives to solve chain rule problems. Whenever we have to solve problems of chain rule, what we will do, we will try to find the relation that where the functions are related. For example, in this first problem, which is a simple category problem, you can see 6x square plus 7x and whole bracket to the power 4. So what is basically, it is in the form. So if you can see, these are algebraic terms inside and there is number outside. So what is the standard form I have in the derivative formula for that? So I have ddx of x to the power n. This is the standard form which I can compare this problem with. So what is the formula for that? It is n x to the power n minus 1. But this is not x there. In place of x, what is there? 6x square plus 7x. So this becomes a problem of chain rule. So now what we are going to do, we are going to apply derivative on both sides as we are differentiating with respect to x. So dy by dx, and same I am applying ddx on the function 6x square plus 7x to the power 4. Now when we are comparing, this is becoming actually x in our problem, and what is n? In place of n, we can say in our problem it is 4. So when we apply x to the power n formula, so how it will become? 4 will come in front like n, and 6x squared plus 7x and 4 minus 1 will become 3. So my formula application for x to the power n is done. But here in problem it is not x, it is 6x square plus 7x. Standard form is disturbed. So what we will do then we will take ddx of 6x squared plus 7x. It means that whatever is inside function, I have taken derivative of that function. You know, we can take by taking u, this is a u and we are making chain of functions, we can do like that. But you know, when the problem is complicated, in that case students find it difficult to take uv like that. So we have to learn direct methodology. It will be easy for us to understand, and I'm sure by the end of this video you are going to understand this method very clearly. Now what is ddx of 6? 6 is a constant in multiplication, so I am writing like that. And what is ddx of x square? Again x to the power n formula, so this will be 2 into x to the power 2 minus 1. And 7 is a constant. And what is ddx of x? So ddx of x is nothing but 1. So in place of this I am putting 1. So I got the answer for the first problem, which is 6x squared plus 7x whole cube. And I'm multiplying 6 and 2, it will become 12, x to the power 1, I'm not writing anything in the power right now, plus 7. So in this way we have obtained derivative by chain rule for the first problem. I hope you understood. Please continue with all the problems. I am going to tell you how to identify and apply the problem. Moving towards to the second problem. In second problem, which standard form we can compare with? So you can see log there. So we are having formula for that. That derivative of log x is what? 1 over x. But what is the disturbed form here? In place of x, what we are having? This whole bracket. So this is a disturbed function and we need to apply chain rule of differentiation. So let's solve quickly. When we take derivative dy by dx, and again I am applying derivative here on the function ln of 1 minus 5y square plus y cube. When I apply the formula, actually I'm going to apply formula first on outside function. What is that? Ln. And ln of x is what? 1 over x. So in place of x we are having that bracket. So when we apply this derivative formula over ln, it will be 1 over 1 minus 5y square plus y cube. But what is the disturbing function here? In the bracket, that is different from x. So this is ddx of 1 minus 5y square plus y cube. Now whatever thing I have written in blue, that is going to follow till the end. No change in that because we have already applied the derivative formula, but for red one we are going to apply. There is minus or plus sign in between, so I am going to distribute derivative to each and every term. Derivative of 1, so I know the derivative of constant is 0, so 0. 5 is in multiplication, that's why 5 is saved. Otherwise if 5 is only there, then you would have taken 0 for that too. But right now 5 is like that, and y square derivative will be 2y and y cube will be 3y square. Okay, only thing is we have to multiply and then we get the answer of second problem as well. Only thing is that we need to understand what is the disturbing function here. I am writing positive term first, and 5 times 2 is 10, 10y. This is the answer for the second problem. Okay, quickly moving towards the third one. Here in this problem you can see two sine terms. So this problem is little difficult as compared to the two previous problems, but yes, it is not impossible. But you have to understand the difference. What kind of things are they? One is sine z to the power 6 and another is sine 6 to the power z. You know, when we apply the derivative over here, so which function is coming first in sine z to the power 6? I can see that sine is coming first because z to the power 6 isn't inside. So I will say that I will apply formula for sine. Then I will apply formula for x to the power n, because again there is not only z, there is z to the power 6. So these two formulae we have to apply in terms of chain rule for the first function. But in the second one, it is sine to the power 6z, means I can write like this, sine z to the power 6. So which formula I will apply first when I apply derivative here? So I cannot apply right now on sine because it is trapped by the power 6. So I have to apply first the formula x to the power n, and then I will apply the formula of sine. So in this way there is a difference in applying the derivative formula for both the functions. Okay, so let's start and understand how we are going to apply. I have explained you the number of steps. Now we are going to apply in the example. So this is, and here one more thing, variable is not x, so I'm not writing ddx. Here variable is z, so I'm writing ddz of hz equals to ddz of, there are two functions, so I am giving them separately, sine z to the power 6 plus ddz of sine 6 and z. Alright, there are two separate functions. Okay, two different type of sine functions are there. In other notation we can write h prime z also for derivative we can write. Okay, and then when we are applying, before applying, what I am doing here, first I can see here sine, so I am just writing for understanding that I am going to apply first formula for sine and then for x to the power. If you're getting confused, then I can say z to the power n formula. And in the second one we are going to apply z to the power n first, and then we are going to apply sine formula. Okay, so in next step then we are applying. Okay, so what is derivative of sine? Sine is cos. So you are not going to apply 6z to the power 5 now only. First only formula for sine. So sine will be cos and angle will be like that. But now I will write derivative of disturbed function. What is disturbed function? Z to the power 6. Okay, then derivative of, now we are applying here, so I can see power 6 before sine, so I need to apply x to the power n formula or z to the power n formula, according to that it will be like this: 6 sine z to the power 6 minus 1, but in place of variable I am having sine z, so I am writing ddz of sine z. Only red terms we need to simplify, that will give us the final answer. So cos z to the power 6 into, what is derivative of z to the power 6? It will be 6 z to the power 5. Yes, we are going to decrease one power after applying the formula. This is sine z to the power 5, and derivative of sine z will be cos z. So finally I am going to write the answer of my problem, which is h prime z equals to 6 constant. I am writing first z to the power 5 cos z to the power 6 plus 6 sine to the power 5z into cos z. So I hope you have followed this problem. Last two are little complicated because there somewhere we have to apply product rule and quotient rule too, but definitely we can solve together. In this problem, you can pause it and think over it, which is the outside function you can see when you take the derivative. Given function is in terms of f of x, so when we are applying derivative, definitely we are going to take ddx of f of x and ddx of whatever function is given there. It is cos of x square e to the power x. You are thinking correct. What is the outside function here? It is cos. So how we are going to follow the procedure in this problem when we apply chain rule? So what we are going to do, first function is there cos, then inside you can see product of two functions, algebraic and exponential. So whenever there is product, so in that case you need to apply product rule. So here in this problem, first we have to apply formula of cos into derivative of inside function, and then we have to apply the product rule. Alright, so let's start the problem. ddx of cos. What is derivative of cos? It is minus sine x, but in place of x, disturbing function is here. Okay, so this will be minus sine. We'll write this function like that only, but after this we'll take product of disturbing function, which is x square e to the power x. Now you know one thing is good in this problem, x square is in standard form, x to the power n, and e to the power x is also in a standard form. So now there is no scope of chain rule, only you have to apply product formula. So just for your convenience I am writing what is product formula. If u into v is there, so u into v prime plus v into u prime. Prime means their derivatives. Simple logic is that whenever you have to apply product rule, what you will do, you will write one function as it is, derivative of second, then derivative of second, and first function as it is, like that. Again, we are not jumping into particularly taking u, v and then trying to find the answer. We are going to do it directly. How? I am saying that you are taking one function as pink and other is green. Now what we will do, first function is x square. Okay, so x square is like that. Derivative of second function, what is derivative of e to the power x? It is e to the power x. Then e to the power x as it is, second function no change, into derivative of first function. What is first function? X square. So this is twice x. So finally this is done. Only thing was here we have to apply product rule. This was little complicated and some students get confused. So we need to identify what kind of functions are there in the problem, and accordingly we can work out. You know, in the bracket there is one synchronized term you can see, that x e to the power x, so you can take out common if simplification is required, or I can say some proof that problems are there. Otherwise this answer is sufficient. And derivative of f of x, I can write it as f prime of x2. So this is the solution of fourth problem, and finally we are going to solve the fifth problem now. In fifth problem you can see there is a fraction and x terms are there in numerator and denominator. When we take derivative on both sides, so what will happen? You can see that here we have to apply on the right side quotient rule of differentiation. So what is the formula? d dx of u by v equals to v square in the denominator, v into u prime minus u into v prime. Here if we say that what is v, so actually denominator is representing v, so x plus tan 12x, and wherever there is u means we have to write 1 plus e to the power minus 2x. So in this way we get an expression in terms of given terms. Now I have calculated the derivative of prime terms here. You can see that when we apply derivative on this function, so derivative of 1 will be 0 and derivative of e to the power minus 2x will be e to the power minus 2x, and 2x derivative will be minus 2. So in total we get answer as minus 2 e to the power minus 2x. And for this second denominator term, when we have to take its derivative, so derivative of x will be 1. Tan, so first you have to apply for tan, it will be sec square 12x, and derivative of 12x will be 12. So this is the answer for the denominator derivative. So what we can do, you can write in the next step, not by erasing them. Okay, so I am writing in place of this prime, I am going to put the answers, and that will be the final answer for this first problem. So what is the value for first derivative? It is minus 2 e to the power minus 2x, and second answer is 1 plus sec square 1 plus 12 times. Alright, 12 times sec square of 12x. So this is the answer for the given problem. So I hope you understood. So thank you so much for your time. Please practice these problems, and whatever doubts you have you can post in the comments and we'll definitely follow them. Thank you so much. Take care. Bye bye.